So I'm Régis, I'm machine learning engineer at Hugging Face, and I'm going to talk to you today about what is Hugging Face, what we do, why we try to push for open source as much as possible. And I'm going to finish the presentation with a quick demonstration about the kind of thing you can do with open source AI. And to start with, just a few facts about the company, about Hugging Face. So the company was founded in 2016, and originally it was supposed to be a chatbot. So for those of you who already know the company, you're probably aware that it's actually not a chatbot, because the company evolved and 7 years ago, in 2017, when the Transformers revolution happened. So that's what Brian talked in the first talk of the day. Google released a paper and they released a model which was called BERT, which was an encoder type of model. And at that time, it was a really great model for doing like text classification, question answering, and things like this. But one issue is that there was no open source implementation. And one person at Hugging Face, so at that time there were like 5, 6 employees in the company. So it was really at the beginning. So one person in the company thought, okay, I'm going to implement it myself and to release an open source implementation. So it was published on GitHub and anyone could have access to the code. And after a while, they noticed that people were really interested in it. And they decided to keep doing it. So when like a new good model was released, they thought, okay, we are going in the same repository to gather open source implementations for all these models. And that's how it started, and that led to all the things I'm going to talk about today. And right now, so the company has grown quite a lot, and we are more than 200 members. With our biggest office in France, in Paris. And the first thing I want to focus on today is the hub, the Hugging Face hub, that you can reach at hf.co or huggingface.co. That's our website. Basically on the hub, you can find many things. You can find like models, data sets, spaces that I'm going to talk about later. But yeah, the first thing I want to focus on is the models. So you will arrive on the hub and you will see that you can search for models by their name, by tasks. So if you want to do image classification, you will find a model. If you want to do speech recognition, if you want to do question answering, you will find a model for that. So you can search more than 1 million models that are on the hub. And you can do pretty much the same for data sets. So basically, right now, there are more than 200,000 data sets on the hub. And you can search data sets also by modalities, whether you want images, text, any kind of thing like tabular data, you're going to find it. And with all this, we serve about 6 petabytes daily, which represents about 1 billion requests every day. So the second thing I want to focus on is the libraries that we develop and maintain at Hugging Face. So here is a short list, but there are many more libraries than this. Actually, if you visit the GitHub page of Hugging Face, you will see all the GitHub repositories and libraries that we develop and maintain. So Transformers is probably the most famous one, and that's actually this library that was started like 7 years ago, the story I told you at the beginning, which gathers implementations for many models that are released in the AI community. But there are also other libraries for other things. For example, diffusers, if you want to text-to-image generation, other libraries like Accelerate, Optimum, if you want to have more optimized implementations of the models, or if you want to deploy your models on a specific hardware that is not like a traditional GPU, let's say. And basically, all this is open source. So that means that the libraries, the code of the libraries is publicly accessible. It's on GitHub. So if you want, you can check it. You can have a look at the code. You can contribute if you want, because, I don't know, like you may find a bug, you may find something that can be like, you would like to have it in the library, it's not there, so you can basically contribute to the library. And also on the hub, all the models, the data sets are publicly accessible. So that means for a data set, you can like look at all the images or the data that are inside those data sets, and the models the same. The implementation is already public, since it will be in transformers or in some other of our libraries. And the parameters of the models are also fully public. So now that I've like detailed a bit more what open source means for us, let's see like a comparison between open source and closed source or proprietary APIs. So there are a few examples here of companies that provide open source APIs, so like us, for example, and other companies that provide closed or proprietary APIs, so OpenAI being the most famous one. And the first criterion I want to focus on is the security. So if you use a proprietary API like the one provided by OpenAI, so for example, if you use ChatGPT, basically what you're doing is that you send them your data, they do some kind of processing with their model, and they are going to return you an output. But this processing that they do, you basically don't know what actually happens. You just get a good output, usually good output. But that means that, for example, if you have sensitive data, you have to send this data to them. With like an open source workflow, you can host yourself everything, and the data can stay in your own environment. The second aspect I want to talk about is the control. Like, since the whole workflow with open source, you will have control about it. You like can modify anything. You are going to be the one controlling the updates that you bring, which means that you can like delay it a bit if you're not sure about it, but you are truly in control of that. When OpenAI updates the model that is behind ChatGPT, they are not going to tell you, okay, we are going to update our model, are you okay with that? Or not. They are not going to do that with all their customers. So that means that from one day to another, they can update their model, and of course they have probably, I guess, a lot of internal testing, but maybe the output is going to change a bit, you know, and you are going to like wonder, okay, that's weird, like the output is not exactly the same that I got yesterday, that's a bit weird. And you have no control about that. You cannot ask OpenAI to just revert the update they made. So with an open source workflow, you have full control about it. The third point I want to focus on is customization. Since you have access to all the parts of the workflow, whether it is the model, whether it is pre-processing, post-processing, the way you serve your model, you can basically like take open source code as a basis and modify it so that it's fully suited for your needs. So you can just customize it the way you want. With a closed source API, obviously you don't have access to the code, and you don't have much control about things that you would like to have available in this code. So you cannot really have a say in like the changes that these companies are going to bring to their API. Then about the transparency. So of course, since open source repositories are public, anyone can inspect the code, anyone can audit the code, which means that developers, for example, they can find any bug, and then they are going to open a pull request to fix this bug, and we are going to merge it, and the bug will be fixed. But if you want to do like a kind of security audit of the code, you can do it. While with closed source companies, basically, you cannot do that since the code is not publicly available. So it's hard to like fully trust them or know exactly what will happen in their code. Like you can, for example, send your data to them, and you don't really know sometimes if they are going to use your data for like training their models. Sometimes there is an option to opt out and to say basically, I don't want you to use my data for training, but sometimes it's not super clear either. So that's really something that is like really important about open source is the transparency. And then the cost. So the cost, I think, it's like there are advantages, I think, to use closed source APIs. For example, especially at the beginning of your project. Let's say you have a use case in mind. You want to quickly start a prototype. I think in that case, it's good because you have just like paying a license, you will have access to a very good model. You can test your use case and you can validate it. But then if you launch your product and at some point the number of requests you get will increase, will grow, at some point it's going to cost quite a lot to pay for this license and to send so many requests to the closed source API provider. So at that point, I think it's much more interesting to use an open source strategy because first, since you have control over the whole workflow, you can decide to optimize whatever in this workflow. And then you can use much smaller models. What I mean here is that when you use ChatGPT, it's a super big model. So Brian talked about it, about 1 trillion parameters. Serving a model like this costs a lot of money, and OpenAI loses money every year. Because, I mean, this model can do a lot of different things. But you, for your product, for your use case, you don't want your model to be able to do this or that. You just want it to be good at the use case you want to solve. So basically, that means that you can take a much smaller model, fine-tune it, train it on your own data, make sure that it performs as well as you expect, and then just deploy it and use it in production. And with a much smaller model, you can have similar or sometimes even better results than using like the closed source API provided by these companies. And since it's much smaller, it will be much easier to serve it, and it will cost much less. So these are all, I think, the advantages of having an open source strategy. And now I'm going to show you what are the tools that we develop at Hugging Face for achieving that. So basically, there are a lot of different tools that we work on. So the first one, the first part, I'm going to talk about it very briefly. It's about data sets and models. So it's linked to what I said at the beginning. Basically, you are going to find on the hub a lot of different models, a lot of different data sets. So you can choose a model that seems to be a good fit for your use case. Then you can find a data set that also seems like a good fit for your use case. Fine-tune this model and try to see if it's good enough, and if not, maybe getting a little bit more data or doing a few things, maybe add like some customization in the model or in the whole workflow. But once you have this, how do you deploy it? So there are two aspects to this point. So the first one, so below we have like, I talked already about like the libraries we develop at Hugging Face. So some of these libraries will basically enable you to deploy your model on not only NVIDIA GPUs, but on some other kind of hardware. So for example, if you want to use AMD GPUs, if you want to use Intel CPUs, Google TPUs, the hardware that AWS also builds, you can. We have libraries for this. And the goal is to make it user-friendly, but optimized for this hardware. And then you can also choose the cloud provider where you want to deploy your model if you want to deploy it in the cloud. So we have partnerships with AWS, with Google Cloud, with Azure, with the DGX Cloud from NVIDIA. So you can choose the cloud provider, you can choose the region in which you want to deploy your model. And this can be done actually pretty easily using, for example, inference endpoints. So it's a graphical user interface where you're just going to say, okay, I want to create an endpoint. Here's my model. Here's the cloud provider I want to use. Here's the region I want to deploy my model into. And then you just have to click on a button and your model is going to be served. And you can start sending requests to this endpoint and getting outputs. Then, of course, you don't have to do the whole workflow using our tools. If there are some parts of the workflow you want to do yourself, you can do it. I mean, all these are open source tools, so you can use it the way you want. It happens also that we have like some people in the company that sometimes some companies, they reach out to us and they tell us, okay, can you help us like doing, for example, this or that? So we help them, and in that case, yeah, we can do that. And then I'm going to talk about spaces, Hugging Face spaces. So those are demonstrations that you can do. Like it's a very easy way of prototyping, of showcasing a use case. So on spaces, you can like basically, it's on the hub, you can look for many different things, especially leaderboard spaces. I think those are very interesting if you are looking for something very specific, like for example, the best model in Spanish language, or the best model for classifying images, or things like this. You can do a search and you can find some of these leaderboards, which I'm going to show some example. First example of space that I want to show you, this was done 2 years ago in a hackathon, which was focusing on the Spanish language. So one team decided to create a space about Spanish to Nahuatl translation. So this is a way of, like you see, it's like a small application and you can just enter an input, submit it, and you will get the translation. Here, it's a leaderboard, so Spanish embeddings leaderboard. So if you want to find the best model for embeddings in Spanish, you can go to this space and you will find it. And so I want to show you like live actually how it looks like and what you can do with this. So I'm going to do a quick demo. Here is the link if you want to also use it. Like you can do it on your mobile phone if you want. Basically, the code is not run locally; it's run on our infrastructure. And this is a text-to-image generation example, which relies on an open source model that is implemented in one of our libraries. And like the people, so here Black Forest Lab is the name of the organization that created this model. They created a space to showcase what this model can do. And I'm going to show you right now. So here, for example, you can enter a prompt. So I think, yes, there are already like a few example prompts. So for example, so the first one, so it says a cat holding a sign that says hello world. So this one is quite fast actually because it was cached, because it was an example. But let's try another one. You can actually try it in Spanish if you want. So, for example, let's say un perro tomando una cerveza fresca. So it's going to take like about 10 seconds or so of compute. Okay, he doesn't. Okay, the dog doesn't have the beer. Let's try again. Ah, si, si. Let's see. Let's see if I'm more lucky this time. Yeah, this is better. So you can really like try any kind of prompt you like. As you can see, it can also support like several languages. So of course, it depends on the model you use. But now there are more and more models that are able to manage several languages, and usually English, Spanish, Chinese. I mean, like the most spoken languages in the world are going to be supported. So yeah, feel free to try it. to try the prompt you want, to look for other spaces that are of interest for you. And yeah, that's it. That's everything I wanted to show you.